is Human Readable JavaScript, and I'm Laurie Barth. You can follow me at Laurie on Tech. I tweet quite a bit. I'm a software engineer at JS, which we had a fun announcement yesterday, if you haven't seen it. And I have stickers, so if you would like Gatsby stickers, please come find me afterwards. Cool, so without further ado, a couple questions for you. This is the audience participation portion of this talk, which you all love. So who loves JavaScript? OK, that makes sense. Who hates JavaScript? Judging you all a little more. I like how many of you did both of those, by the way. Who writes JavaScript code? Cool. Who reads JavaScript code? If all of your hands are not up, I'm going to be really surprised. Great. Cool. OK. So I want us to be honest. We're talking about human readable code. JavaScript sucks at this. At least historically, it has been very terrible at being human readable. But before I talk about why this is the case, I want to define what I mean when I say human readable and what I'm actually talking about here. So what is readable code? What do we mean? I love this. Code is for humans to read and machines to interpret. And for a long time, that was the case. But the difference between those two statements was very, very small. For a long time, you had to write in assembly, and you were dealing with bit shift operators and registers, and you were as close to computer-interpreted code as humans could possibly get. And then we abstracted a level up. And then we abstracted a level up from there, and from there, and from there, and now we're in JavaScript. And then we're going to Webflow. But for now, in JavaScript, the reason we have abstracted this far is because we want code to be more human readable. We want to focus on what humans see and understand and comprehend instead of getting as close as possible to ones and zeros. And this quote is really nice. It says, code is readable when it's easy to edit safely. And there's a lot to unpack there, but I want to go through a few specific things. One of those is separation of concerns. We talk about this when we actually architect our applications, but we don't think about this in a line-by-line or even variable-by-variable consideration. When we talk about human-readable code and separation of concerns, it's functions doing one thing only. It's abstracting in a way that actually improves your code instead of makes it more opaque to everybody else. It's a clear structure, getting rid of pyramid code, making it clear that you don't have to scroll through 1,000 lines in a single file to find what you're looking for. It's both in the architecture of your file structure and within your files themselves. And it's expressive code. And what do I mean by this? Well, one of the hallmarks of why coding is so interesting and why we fight about it all the time is that you can do the same exact thing about 20 different ways. And so expressive code is recognizing that reality. It's making the decision that of the 10 ways you have to make this one feature work, you are going to choose the one that is most intuitive, the code that makes the most sense to the person who's never seen this code before the first time they read through it. So JavaScript sucks at this. Why? Why am I being so mean to a language that I literally work with every single day? It's my job. Well, for a long time, it's been incredibly bloated. And I don't mean node modules. That's a whole different talk. It's bloated means we used to insert JavaScript inside script tags. Script tags that could be hidden in any HTML file in your project, and you had no idea where. So we'd start doing stuff like this. Just a caveat before we talk about human-readable JavaScript. If you can use native CSS solutions or semantic HTML, those are your first lines of defense. Don't go to JavaScript unless it's actually needed. You make your life a lot easier. Your code is going to be more readable. But doing stuff like this meant you were kind of always playing a game of hide and seek with where your JavaScript was, what it was doing. And because JavaScript got this reputation for being bloated, everyone decided, okay, yeah, we get it. We're using too much JavaScript. So what if we just make it really, really small and really few characters? And then it's like you almost won't notice it's there. And then we got unintuitive things to accomplish this. I'm sorry, jQuery, I can't defend the $sign. It's just like, what does that mean? Just no. I can defend this as a keyword that you have to learn. $sign, a little bit, not so much. So there's a lot in JavaScript that's unintuitive, very symbols-based. That's somewhat frameworks. And there is stuff that's in the ECMAScript standard, which we'll talk about in a second. But you know how I said JavaScript likes to hide? This is not JavaScript's fault. This is our fault. We decided, and JavaScript developers got the reputation, that if we were really good JavaScript developers, everything could be done in one line. I mean, why do you need more than one line? FizzBuzz, everyone? How many ternary operators are in that? How many lack of spaces? I mean, that's ESLint, right? Use ESLint, use prettier. Those things are helpful. But this is terrible. Like, this is truly awful. And it's not even doing that much. It's doing FizzBuzz. So JavaScript developers decided that because everyone was giving them such crap for bloating up applications and not using semantic HTML or native CSS solutions and just doing whatever they wanted with JavaScript all the time, they would listen to those concerns and just make their lines of code really, really small. It's like they hide in a little corner and you can't see them. Yeah, we don't want to do that. It's not readable. That helps no one. It actually causes even more problems than the whole bloated issue. So you're probably sitting here thinking, not all JavaScript. I write beautiful, readable JavaScript, and I care about both my users and my future self and my colleagues and my managers and anyone who has to do code reviews. OK, that's great. But JavaScript is used a whole lot of places. It's also the de facto language of the web right now. And as a result, if this reputation continues, nobody's going to want to use it. And no one's going to want to read it. Because a lot of the people who have to read JavaScript and look at it and maybe even debug it in certain cases are not JavaScript developers. They're polyglot programmers who are now diving into the world of our weird syntax that we decided was helpful. So things have changed. It's not just that we're the de facto language of the web now. JavaScript can be used for entire applications. We have Node now. JavaScript has so many additions that have made it a stable language to be used for full suite applications, production-level enterprise solutions. That wasn't always the case. We're no longer the little script kiddies in the HTML files. Now we have to act like it. So I'm here to save JavaScript in 35 minutes, right? If you want to learn more about this stuff, there's actually a really great book called Simplifying JavaScript by Joe Morgan. It goes into some of what we're going to talk about today, and it has a slightly different take than I do on specifics, but it's really well written, and it talks a lot about using modern ECMAScript to write code that's more readable for everyone. So along comes ECMAScript. Who knows what ECMAScript is? OK, so some people. So ECMAScript is the standard on which JavaScript is based. ECMAScript is basically saying this is what JavaScript could do. And then it's up to the JavaScript engines to actually support that and say, OK, yeah, JavaScript can do this now. And JavaScript engines exist in a bunch of different places. They exist in Node, which is actually using the V8 engine, which is the same as what's in Chrome, the browser. There's an engine used in Safari, so all the different browsers have their own engines. The JavaScript engines on your phones are actually slightly different in certain cases for browsers. And then you've got Babel, which isn't technically an engine. It's a little bit different, but it's also interpreting ECMAScript. So this is a really nice little chart of ECMAScript additions and where they are supported. If you're familiar with the website caniuse.com, that is actually merging with Mozilla's spreadsheets like this. So it's going to be even more effective about telling you what is supported, where, why, when you can use it. And this is important to note, especially if you're supporting older applications and you have to worry about polyfills for Internet Explorer. So keep this in mind with everything new that comes up and you're looking at. So if you're not familiar with ECMAScript, I actually wrote a post kind of talking about ECMAScript all the way through JSX. You can find it on the blogging site dev, or you can just Google that and it should come up. I think it's actually on the first page of Google, which is kind of fun. OK, so ES2015, it will sometimes be called ES6, was kind of a big departure in the ECMAScript standard. It introduced us to a number of things that we're now familiar with, a couple of which I'm going to mention here. This is the currently most widely supported version of ECMAScript across the web. There are obviously specific ECMAScript additions that are supported, all the way through ES2019, but ES2015 is kind of your baseline in most cases. So without further ado, let's save JavaScript, which means you get to mock me live coding. Isn't that fun? OK, so is this big enough? Yes? OK, so if you are curious, by the way, I'm using a plugin for VS Code called QuokkaJS. And what it's going to do is it's going to show us what our variables would actually look like and what our code would actually compile to if I were running it in my inspector or whatever. But this is prettier and easier to see. OK, so I want to start off with an example to kind of get you in the mindset of thinking about human readability. This is just questions. I'm not going to provide any answers. It's just a mindset thing. So who does functional JavaScript? Some of you? OK, so if you're not familiar, map, reduce, filter, they were added into JavaScript. They allow you to manipulate arrays, which is really nice. But they all take in a function. And in that, we have the arrow function. And that's going to come up in just a second. So we're going to start with an array. Very exciting. And we're going to map it. Whoops. So we're going to start with the tersus version of this. And this is Quokka. That's what's giving you the little blue thing there. That tells you that this is what mapped is equivalent to 246. OK, so this is the function that we are passing into map. It's saying we're going to have an element, and we're going to multiply that element times 2. In the case of map, it is going through each item in our array and passing that element as the element in our new function. So it's kind of a for each. So this is one way to write this, and it is the tersest way to write this function. You can write the exact same thing and add parentheses. Nothing changes in your functionality. What do those two characters add or take away? Do they make a difference at all? Does it matter that if we had two parameters being passed to this function, we wouldn't have a choice? We would have to use the parentheses. What does that mean for consistency? So what if we go a step further and we do this? OK, now we've added a keyword. We've added 2 more characters with braces. What does this do? Is it more or less readable? Does it matter that if we had more than one line in our function, we wouldn't have a choice? We would have to use brackets and a return statement. What does that do for consistency? Let's go a step further. Let's decide that we don't want to use a fat arrow. This does the same thing. What does the function keyword give us? What does it take away? Does someone encountering this feel like they understand what this is meant to be doing, or does it just clutter up your ability to scan? The last thing we can do here is pass just the function. Map knows how to handle this. It knows what to pass. In fact, if you had an index, which is the second thing that map passes in, you could do that as well. You'd be fine. I'll actually do that for us. That all works. Map can figure that out. What does this do? Is this readable? Is someone going to think this is an object instead of a function? Yes, I know the comparison, but just, you know what I mean. If someone scans through this and they know that they're looking for a function, are they going to be able to find it? Where'd you put it? Where'd you define it? What does that mean for understanding what's actually happening here? This is like 20 characters, and I just asked you 20 questions. And I asked you to consider what you're writing. And you've probably sat at your IDE before and written code and not even thought about characters because you had some ESLint rule that just defaults. Who made that ESLint rule, and why did they decide that's what it could be or should be? Have you thought about it? We're here to think about it. So the reason I used this example first and asked all of these questions is because these are the kind of things that human readable code is asking us to consider. It's making the expressive decision the intuitive decision. So that's functional JavaScript. Other thing we added in early days was destructuring assignment. So I'm actually going to start with an object. So destructuring assignment kept us from having to do this, which feels, not so terrible. But what if this is another object? Just gets kind of annoying, right? Like dot, 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 dot. It's not super readable. And if you're using it again and again and again, maybe it's what you want, maybe it's not what you want. Destructuring assignment for objects, we'll get to arrays in just a second, allowed us to add these curly braces and essentially dive in a level deeper. So we can now access this, or thing, sorry. I can't remember what I named things. Naming things is hard. These are terrible names. Human readable JavaScript would never do this, but it's hard to name things in live code at the same time, so cut me a little slack. So we get to pull thing out of here and access it directly. There's a couple of things that are actually nice about this. We don't have to use a new variable name in order to access this. We can use the same one. You don't get confused about the redundancy of that on either side of your expression. The other thing that's really nice about this is the curly braces correspond to curly braces you use to define objects. So that seems to have somewhat of a one-to-one mapping. On the other hand, this is very symbol-based. What does curly braces say to someone who's a polyglot programmer and isn't familiar with JavaScript specifications in particular? Does this help or hurt them? One of the things I want you to understand throughout this talk is regardless of what example we're looking at, the thing that's most important is to consider your audience. The decisions you make are going to be very different depending on who works in your code base. But I don't want you to think about who works in your code base now. I want you to think about who's going to work in your code base. Because if you sit here and say, I'm the only one who ever touches my code, it doesn't matter, that's really great. I hope you never leave your job, and if you ever want to be on a new project for something different, that's never going to happen, right? Because no one's going to understand what you wrote because you wrote it for you. And what's worse is if they pull you onto something else for a little while, you finally got your wish, and they said, oh, you're the only one who knows this legacy system. Can you go back on? We'll say 6 months later, but let's be honest, it could be 2 weeks. You're going to go back to your code and say, what in the world did I write? Right? It takes all about 5 minutes for that to happen. So this isn't just about being kind to your coworkers and your future coworkers. It's also about being kind to yourself. So destructuring assignment can do that. As it turns out, we can also go a level deeper. We can get all the way to A. We can embed these things. We are using the keys that define them. Okay, that's kind of nice. What happens if we do this for arrays? So arrays don't have keys, right? I mean, if you look underneath what's actually happening and how they're defined, yes, they do. But to us, arrays do not have keys. So our variable assignment in this case is based on position. And so we're ignoring the other two items in this array. We can do that just fine. But what if we didn't want to define all these variables that we don't actually want? Commas. We've now ignored these other positions. We can go multiple levels deep if we want. Think about the readability of this. It works. Does anyone actually want to read that or use that? Maybe, maybe not. It's worth considering your use case. Now, my absolute favorite thing about destructuring in arrays is that if you are aware of what's happening underneath in JavaScript, arrays are created as objects under the hood. The only difference is that your keys are numbers. They're your indices. Which means you get to do something like this. Whoops. Did that the opposite way that I wanted. You can use object destructuring on arrays. This, which I didn't do when we had an object, and I meant to, so that was my bad. This is aliasing. You can assign a new named value. That's super, super useful, right? Because in cases where you've ended up with multiple HTTP responses, you may have a million things embedded that are called node or response, and you want to rename them. You can do that on the fly using destructuring. So you get to do really weird stuff like this. You can get the length. There are properties that you can access. There are some cool things here. You can get first and last really easily. What are the other ways to get first and last? Is this better? Is this worse? It's up to you and your use case, but it's nice to know you can do it. So one of my favorite things in destructuring assignment, is this big enough for people in the back, by the way? Yeah? OK, cool. So one of my favorite things with destructuring assignment is this is actually used elsewhere. So how many of you are familiar with the introduction of JavaScript modules? Some of you? OK. So for a long time, if you're familiar with React, they created the idea of components, components that you were going to pass around in your application, import, export, all that jazz. Well, for a long time, they had to build something on top of JavaScript to support this concept. Later on down the road, the idea of JavaScript modules came to the specification. And essentially what it is a standalone, self-contained set of JavaScript functionality. It's like the Docker of JavaScript. That makes sense to no one but me, and that's fine. So they took the ability to do import-export syntax of these components back and forth between your various files and try to make it really straightforward, which is nice. So we are exporting a component here. I'm using React just as an example. That's not the only version of JavaScript modules that exists. But we're exporting this component, and we're using the default keyword. You can use this once per file. You can only have one default, but you can use it. And it means that when you import test from /test, and we add test, we're going to see how good the Wi-Fi is here, by the way. Ooh, nice. You import test. What's interesting to know is that it's just a name assignment. It's essentially positional, like arrays were. So you can make it whatever you want, literally. But what happens if we come in here and the same file has a second export? It can't be default, because we already have a default export. Note that it's called other. If we come over here, oh, weird, that didn't save. That's fun. So let's say we're going to import other from /test, and then we're going to try and access other. That's a problem, right? That's our default export, because it didn't matter what name we gave it. So giving it other, even though that corresponds to something else, isn't going to work. As it turns out, JavaScript modules are objects. And so destructuring requires us to dig a level deeper and access the key named other that corresponds to a component as a value. And we can do both things at the same time. We can get test and other. And if we want to alias other to a different name, I think this is incredibly important for readability, by the way, because half of us don't control our third-party library naming conventions, and being able to rename things to match our conventions and make it clear what that third-party library component or whatever is doing in our code is really useful and important. But it's not the colon that we saw before. It's as. So that's how we do that. But what's interesting is this is a name assignment. If you want to move the default in here, you can. But it's not going to work that way. Because once you move it inside the JavaScript module, it's not looking at the name of the component as the key. If it's default, it considers default to be the key. So we can make default as test. There we go, everything works. But there's a lot of functionality there, and a lot of functionality that makes it easier to give people ideas about what's happening in files and code that they can't see. And they don't necessarily have to go a step further to dive into it to figure out what's happening if you've named it appropriately or you've aliased it appropriately. You can break things down when we talk about those 1,000-line files into smaller things and import them and pass them around and do lots of really nice stuff that was potentially a little more complicated or uglier before. All right, so we're going to go back into this. Now I'm going to get to the part of this talk where I actually talk about a piece of syntax I don't necessarily like. And it's not that I don't like it. I think it's got lots of really nice use cases. I wrote a whole post about it. It is very symbols-based. And to people who don't know what it is, it's really confusing. Which means I am, of course, talking about the spread operator. Yay. Overused. Yeah. OK. So we're going to make a copy of array. And after learning what this is, you can actually make really convoluted logic in your head that explains why this was the symbol chosen. OK, dot, dot, dot. Each of those dots is grabbing each of the elements in array, and dot, dot, dot means infinity. So essentially, it's happening for all of the elements that exist. So we could add 4 and 5, and yeah, that makes perfect sense, right? That only makes sense in my head? No, it probably makes sense to other people, but it's not intuitive when you look at it the first time. It makes a lot more sense if you already know what it is, and then you backtrack to how the symbol was chosen. The reason in particular that I don't necessarily understand this one is because people use it a lot for making multiple arrays. OK, cool. But let me ask you this. Why didn't we just do this? Concat is a verb. It means something. It makes sense. Why did we do the spread operator? Why did we use the spread operator? And if we use the spread operator again and again and again and make multiple arrays this way, concat can do the same thing. There are use cases where you may want one versus the other, but it shouldn't be the default to use the brand new shiny thing in a use case where maybe there's a better alternative. That being said, the spread operator also works for objects. And I don't know about you, but it was never really fun to do this. Yes, I know that's not going to work. I'm typing weirdly. It's fine. It was never really fun to have to concatenate objects. Spread operator makes that a lot easier, and there isn't a great alternative there. There isn't a more expressive alternative there. So maybe that's a case where it makes more sense, or it doesn't. Something to think about. So I've been mean, and I've been nice, and now I get to be new. So ES2018, is 2019? What year are we? You made this joke earlier. I really don't know what year we're in. ES2019, I'm pretty sure. Added a bunch of new stuff, and by now it's 6 months to a year old, so you may be familiar with it. You may not, but we're going to go through a handful of those things. So for a long time, people didn't do as much functional programming in JavaScript, but they started realizing that people ended up with really gnarly things like that. And you know how you fix that? Let's see if I get this right, because I almost never do realistically. Concat.apply. And the fact that I've practiced this so much and I still can't get it right should tell you how gnarly this is. Yes. Why? This is atrocious. Like, horrible, 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 horrible. And it only flattens one level. So there's, yikes. So I've been asking you all these questions. I've been asking you to consider use cases. I've been asking you to do all this. There is no use case where you shouldn't do this. There is none. Flat is your savior. Welcome to JavaScript. What took you so long? Now, what's really nice about flat is it takes a level of depth as an argument. So if we want a fully flattened array, we can pass in 2. Note that the default is that it's lazy. So by default, if you pass in no argument, it's going to fill in 1 for you. If you really want to power move it, you can do this. If you don't know the depth of your array, please don't do this. This is the call stack error in the making, right? Like, no. But flat is really, really, really nice. But part of the reason it existed was for functional JavaScript, and I want to talk about why that is. Well, it was not unreasonable, and they found that it happened very often that people wanted to do this. They wanted to insert stuff into the middle of their arrays. And so you ended up with something like this. And all of a sudden, you're not flat. Well, now with flat, we can do this. We're going to be flat. But they figured this is actually a really common use case to add elements inside our arrays. So they said, OK, we're going to be nice to people. FlatMap. New introduction to the array prototype. Keep in mind, this is equivalent to .map.flat with no arguments. There is no way to pass an argument into this. So if you add another level, it's not going to flatten all the way. And this makes sense. We want it to be lazy by default. We don't want to overcomplicate things, but do keep this in mind when you're using it. Flat's nice. FlatMap's nice. 2 really nice additions to ES2019. But my favorite is yet to come, and let me tell you why. Who thinks that array prototype gets all the love in JavaScript and poor objects get abandoned? Just me? Yes, thank you. I don't know about you, but not all of my data is in array form. A lot of my data is objects, and objects get the shaft. They never get all the manipulation tools that I want because array gets them all. Maybe because it's easier. I don't know. I have no excuses for them. I'm angry with them. So let's make ourselves an array. So one thing to, or an object, wow. One thing to know is that ES2017 introduced us to something called object.entries. And object.entries takes an object. Why does it always do that? IDEs at work, everybody. So it takes an object, and it turns it into its multi-dimensional array representation. And that's nice, because it allows you to use all of those manipulation techniques that we know exist for arrays. So array.map, again, I'm going to use the terse version just because it's faster. And then we're going to return. I always do this wrong when I'm live coding because this is my life. Oh, I know what I'm doing wrong. Okay. that work? Let's find out. Yes. OK, cool. So you get to use all of these really nice things. Map, filter, reduce. Mostly don't use reduce, but that's a whole other conversation. Map, filter, reduce, flatMap, all these really nice things. But to actually get your object back, which is what you started with, let's do this. This is going to be fun. OK, so for let key value, this is destructuring, in mapped new new key equals value. This is fun. Everyone having fun? Yeah, this is fun. Yeah, I knew I was gonna. I think it's of. Yeah, there you go. That's not fun. This is just no. So in ES2015, we got my favorite thing ever. Boom. Object up from entries. You can turn your multidimensional array back into an object, which was something we were missing. Now, I want you to keep in mind that if you start with something that looks like mapped, if you never have an object, you probably don't want object.fromEntries unless you are super, super sure that you're not going to have duplicate keys. Arrays and objects are different data structures for a reason. They can't be treated identical. However, if you start with an object, you turn it into an array, and you turn it back into an object, you're probably pretty OK. It's a really nice addition. So we have all of these lovely little things that I've added. But one thing you didn't know about me is that I am on TC39, which is the ECMAScript Standards Committee that decides what's new to the JavaScript language. And I'm not on TC39 like in the room to decide what's being added, because I don't have time to travel that much. I travel enough for conferences. I'm on the Educators Committee, because all of my job in my entire life, everywhere I go, is to teach people how to use, well, mainly JavaScript. And so one thing I know is that there's a couple things coming to the standard that I think you all might be curious about. So we're going to talk about those. This is ES2020-ish. These things are in stage 3. They've been implemented in Babel. In order to get to stage 3, you have to be implemented in Babel. The other thing to keep in mind is actually some of these already exist in TypeScript, because TypeScript said, yeah, we think they're going to get to stage 4, so we're going to add them in. One of these was introduced to V8 and exists in Chrome for a period of time. They actually had to roll it back because it caused an issue. And I think it's back in there now. But this is what you notice with bleeding edge JavaScript. It's some places, it's not other places. So probably not ripe for use in a production application just yet. But these are really nice things that I would like us to know that they exist. So the first thing we're going to talk about is nullish coalescing. Who named that? Nah, it's fine. So I don't know about any of you, but has everyone seen the WAT video? OK, so if you haven't, look it up. It's the funniest JavaScript talk that has ever existed. It's only about 5 minutes. It'll make your life. It's W-A-T. But they give JavaScript a lot of crap for things it does that don't really make sense. One of the things that causes a lot of that doesn't really make sense is falsy values in JavaScript. So we're going to set this to 1 for now. For a long time, people have used the OR symbol to get defaults. OK, so 1 actually exists. This is a thing. If I get null, I get 2. That's what I expect. What about 0? 0 is falsy. I get default. But I was expecting a number that doesn't make sense. Why can't I make 0 a value that's valid? Yeah, this gives people errors and headaches literally all day, every day. So this isn't going to work in Quokka because it doesn't exist in JavaScript yet. But coming to the specification is nullish coalescing. 2 question marks. Keep in mind that this is very symbol-based. I don't know about the readability of this one, but we have the 2 lines for OR, we have the 2 ampersands for AND, so maybe this will continue as something that people kind of learn as part of the spec. So 2 question marks mean the following. If this is null, we get 2. If this is undefined, we get 2. Any other value will be the value. This ignores falsy cases. It only listens to null and undefined. And that's really, really nice, because we've been missing this for a while. But you may be wondering why, in particular, this seems to come up. Well, it's because of another thing that we're adding. Let's get rid of all this. We're going to make some embedded nonsense. We won't make it too embedded. So let someone give me a name. Bob. What? Bob. I heard Bob. I don't know if that was actually the name given to me, but I heard Bob. So Bob is 1. I hope you're not 1, because you probably didn't understand any of this, but we'll go with it. OK, so this is the thing we can do, right? We can access all of these things. What if this doesn't exist? Error, error, error. That's not a bad thing. We probably should defensively program, right? That's a good thing. But people always say this when they control their own data. And I don't know about you, but I don't always control my own data. And I have a particular use case that I remember. It was my first year of programming, and we were interfacing with the Juniper routers, which are DDoS routers, getting millions of traffic hits a minute. And they had these really, really gnarly embedded objects that were returned to us, of which we wanted a value like 5 levels in that was sometimes there, sometimes wasn't. And there were 5 other levels to get there that were sometimes there, sometimes wasn't. And it was terrible. It was like 30 lines of code just to get this one value. And the thing was, we didn't care if it wasn't there and if all the other stuff wasn't there. We only wanted the thing all the way at the end, and if it didn't exist, we'd say no. I am not the only one who has ever come across this. So, optional chaining. Question mark, dot. This means this isn't going to error out anymore. It's just going to be null or undefined, which is why this ends up mattering quite a lot. Because nullish coalescing allows you to get a default. Here's the problem. There are a lot of people, this is going to pass, this is going to be in the spec, but there's a lot of people who really don't want it to be in the spec for JavaScript, because they're afraid that everyone who ever wants to access anything is always going to use this syntax. And you're going to get a lot of silent errors if you do. You should not use this if you control your data. Be a good programmer. Be defensive. If you don't control your data and you have a very specific use case, this is going to come in really handy. Now, what I want you to notice is that these are question marks in front of dots, which means you can also do this, and you can also do this. You can use optional chaining for array elements and function access as well. It's pretty nice. And nullish coalescing is always the same. So, I always love doing this at the end because it's kind of hilarious watching it happen. So things we went through. Map. That's going to work just fine. And then we went through destructuring assignment. Doing this in an IDE is going to be funny because it's going to try and autocomplete weird stuff. So destructuring assignment, import, export, spread operator, flat. See? Now, stop it. Yes. FlatMap. Object dot entries. Yep. Object dot from entries. Nullish coalescing. Yeah, that's actually how it's spelled. And optional chaining. So we learned a lot of stuff today. Some of these you may be familiar with, some of these you may not be. There may be specific use cases. We uncovered all of that. But what I want you to recognize is that we learned all of this stuff with readability in mind. Recognizing that new things are not always the best things, and that in general you want to be really cautious and intentional about what you create. You want to think about your audience. You want to think about your coworkers. And that has been 45 minutes, so I got to let you go. But thank you very much.